diagram here shows the graph of the function f of x, right? So that's the function f of x there, this curve, and it's shown between the values for x greater than or equal to 0 and less than or equal to 5. Okay, then part A, the function g is g of x equals x plus 3. The first thing to note here is that this thing here is a line, a straight line, because the highest power of x is 1. And then we're asked to get the points A and B, and these points we're told are the points of intersection of f and g. So this is where the straight line crosses the curve, and they supply us with half of the coordinates of A. So they tell us that A is 1 and k, where k stands for some number. Okay, so we can feed the coordinate x equals 1 into our function g of x. So we're going to get g of 1. G of 1 equals, when x is 1, 1 plus 3 equals 4. So that gives us the point with the coordinates 1, 4. And this is A. A is 1, 4. So we could graph that there. Draw it in on the graph there. A, that's A. 1, 4. Now we have to get B. Now there's a couple of ways of doing this, but we can examine this line here, g of x equals x plus 3. And we can compare that to the classic form for a straight line, y equals mx plus c, where m is the slope and c is the y-intercept. So we can see there that c equals 3, which gives, so that's the y-intercept, so that gives us the 0, 3 for our y-intercept. And we can draw that on our line 0 and 3 for our y value, and that point there is also on the line g of x. If we feed in 0 for x to test it out, g of 0 equals 0 plus 3, so 0, 3 is on the line g of x. And then we can draw that line onto our graph, and that will be fairly helpful. And we can see that that straight line crosses our graph here at the point A, and here at this point, which is 3, 6. So that would imply that B equals 3, 6. We can mark it in there, B. Now we can check that out by feeding 3 as our x value into our g of x function. So try that out. G of 3 equals 3 plus 3 equals 6. So that gives us the point 3, 6 is on the line g of x, so that checks out. And we can also feed in x equals 3 into our f of x function to check things out. So f of x, f of 3 equals 5 times 3 minus 3 squared, which is equal to 15 minus 9, which is also equal to 6. So that checks out. So we can say that the 2 points A and B are the points of intersection of our curve f of x and our straight line there g of x. So we can mark that straight line there g of x. Then in part 2 we're told that the points 0 and C are on the graph of f, and they want us to draw the quadrilateral. Quadrilateral just means 4 sides, so it's a 4-sided shape, and we want to mark in 0, or point O, 0, 0. Well, there's point O, 0, 0. We can mark that in as O. And point C is 5, 0. So starting at the origin, 5 out, 0 up or down, and that there is point C. So we want to draw our shape, so maybe I'll select a different colour. And that's one side there from O to C. O to C. Then from C to B is our next side. Then from B to A, which is superimposed on our G of X line. And then finally from A back down to 0, which is kind of on this curvy line, but not quite. So that's our four-sided shape, OCBA. 1, 2, 3, 4. Quadrilateral, 4 sides. So we've drawn that on the diagram, and now part 2, we want to find the area of quadrilateral OCBA. And the handiest way to do this is to divide this guy, this quadrilateral shape. I'm going to dash line down here, dash line down vertically from B, and now you can see that's a triangle, that's a triangle, and if I go across here I can chop off this shape. So shape 1 is a triangle, shape 2 is a rectangle, 3 is a triangle, and 4 is a triangle. So it's no big deal to get the areas of the individual shapes. So we're just going to get the areas. So area 1 is half the multiplied by the base multiplied by the height. That's the formula for the area of a triangle. And our base here is 1 unit, so we have a half multiplied by 1 multiplied by the height, which is going from 0 up to 4. So we bang them into the calculator, or you could just say 1 times 4 is 4, and half of that is 2. So that's the area of shape 1, triangle 1. And now we're going to get the area of shape 2, which is a rectangle. And the formula for the area of a rectangle is the length by the base, or the length by the height. The length of our rectangle here is 4 units, and the width is 2 units. So we have 4 multiplied by 2, and that gives us 8 square units for the area of rectangle 2. Now we're looking at shape 3 there, looking at the area of piece 3 in our diagram. That's a triangle again, so half times the base times the height, and we have a half multiplied by the base there. You can see it goes from 1 to 3. 3 minus 1 is 2 units for the base, and the height goes from 4 up to 6, so that's also 2 units. So it's really going to be a half multiplied by 4, and that's going to give us 2 units. Finally, we have shape 4, which is another triangle. The base is 2 and the height is 6. So shape 4, half times the base times the height. The base is half times, what did we say the base was? 2 units, times the height was 6 units. 2 6s are 12, and half of that is 6. So we just add up these areas, and we get 4 and 4 there is 2 and 2 is 4, and 6 is 10, and 8 is 18. 18 square units. And that is the area of our quadrilateral OCBA. 18 square units.